At some point more than 230 million years ago, there were no dinosaurs anywhere on Earth. No Tyrannosaurus rex, or Triceratops, or 100-foot sauropods. And then, somewhere on the supercontinent Pangaea, a population of small reptiles crossed an evolutionary threshold which would eventually create absolutely all of them. The weird part here is that we still haven't found a dinosaur that everyone agrees was the first, because by the time dinosaurs clearly appeared in the fossil record, there are already several different kinds of them, which means that the beginning is missing. But a handful of bones discovered in Tanzania almost a century ago may be the closest we have ever come to finding it. Around 230 million years ago, almost all of Earth's land was connected into the supercontinent Pangaea. But if you time travel to one of Pangaea's forests, the world wouldn't immediately look like the age of dinosaurs. In Argentina's East Quilguasto Formation, some of the best fossils from this time preserve a full terrestrial community. There were cynodonts, animals on the evolutionary line toward mammals. There were also rhynchosaurs, these robust herbivorous reptiles with a beak that were some of the most widespread plant eaters in these environments. There were large predatory relatives of crocodilians, armored adosaurs, strange archosaurs, and many other groups that have no exact equivalent today. And among them, we had the dinosaurs. But they were not yet the rulers of this world. In an interval of the East Quilguasto Formation, dinosaurs account for only around 11% of the vertebrate specimens. Much of the ecosystem was still dominated by completely different groups of animals. This is important because the first dinosaur did not evolve into an empty world waiting for dinosaurs to take over. Rather, it evolved into one of the most unusual and competitive ecosystems in the history of life. And this creates a difficult question. What actually makes something a dinosaur? Because being large doesn't cut it, or just having scales, or being extinct, or walking on two legs. Those are characteristics shared by other groups as well. Dinosaurs are one branch of a much larger family called the archosaurs, which is the group that survives today as crocodilians and birds, but back in the Triassic included an enormous variety of animals. What separates dinosaurs from their closest relatives is a collection of subtle skeletal changes. The focus here is the skeleton. Many involve the pelvis and the legs. The connection between the backbone and the hips also became reinforced. Dinosaurs possess a modified sacrum, incorporating multiple vertebrae. Their limbs became arranged underneath the body, rather than sprawling outward in the way that we imagine many reptiles used to walk. These changes sound like pretty small compared to something like the neck of a brachiosaurus or the skull of a triceratops. But at the beginning, this is what dinosaur evolution looked like. It wasn't giant predators appearing in a few million years. It was essentially tiny anatomical differences accumulating in animals that still look pretty similar to their closest relatives. And at this point, the fossil record becomes a bit weird. The oldest dinosaurs that scientists can identify with confidence are approximately 230 million years old. But there isn't just one. In South America, there's Herrerasaurus, a somewhat large carnivorous dinosaur. There's also Eodromius, a lightweight predator near the base of the evolution of theropods. We also have Eoraptor, whose position has been debated, but it's been considered an early member of the sauropodomorph lineage. There are additional early dinosaurs from Argentina and Brazil. The problem is that these animals are already different from one another. By this point, dinosaurs had already begun experimenting with different diets, body plans, and evolutionary trajectories. The earliest definitive dinosaur record is really a picture of a world in which dinosaur evolution is already underway. It isn't a sudden change, and that means that somewhere there should be an earlier chapter. For years, it appeared to be missing. But in the 1930s, fossils were collected from the Manda beds of southern Tanzania. They weren't particularly unique or different. We didn't even have a skull, or jaws full of teeth, or even a complete skeleton. The main specimen is made up of a part of a right upper arm bone and several vertebrae. And because it was so fragmentary, it wasn't that popular for a long time. It was tucked away, but those scraps came from rocks around 240 million years old. This is potentially 10 to 15 million years before the oldest unquestionable dinosaurs. The animal would eventually be named Nyasasaurus parringtoni. But the cool thing for us was that inside those few bones were features that made it hard to ignore. The upper arm bone has a long, pronounced ridge called the deltopectoral crest. In dinosaurs, This structure is enlarged and is linked with attachment of muscles controlling the forelimb. Nyasasaurus has a form of this crest, which is considered strongly dinosaur-like. Then there are the vertebrae. 3 appear to have formed part of the sacrum, which is the reinforced section of the backbone connected to the pelvis. Again, this is one of the features associated with dinosaurs, and scientists were even able to cut into the arm bone and examine its microscopic structure. Its bone was highly vascularized and showed evidence of rapid growth, which is way more similar to early dinosaurs than to dinosaur relatives. So you have an animal from before the accepted dinosaur fossil record with dinosaur-like anatomy and dinosaur-like growth. But the problem is that almost everything else that could settle the question is gone. We just don't have the evidence. When Nyasasaurus was formally described, the researchers arrived at an appropriate conclusion. It was either the earliest known dinosaur or the closest known relative of dinosaurs. And with the material we currently have, figuring out on which side it actually lands is extremely challenging, which makes Nyasasaurus almost the idyllic fossil for the origin of dinosaurs, because we can't truly see a clear dividing line with evolution. The idea of a dinosaur is basically a boundary that we draw on an evolutionary tree after hundreds of millions of years have passed, and Nyasasaurus appears to sit almost directly on that boundary, which makes it all the more fascinating. Unfortunately, that also means reconstructions of Nyasasaurus contain a considerable amount of inference. We're kind of guessing here. We don't have its head. We don't even know exactly what its hands look like. We also don't have a full understanding of its proportions. Based on the vertebrae, the original description estimated an animal perhaps 2 to 3 meters long. And by comparing the earliest dinosaurs and their closest relatives, the ancestral dinosaur was probably a small, active animal that moved on 2 legs, with forelimbs adapted for grasping. Its diet is harder to figure out. The earliest members of the group likely fell somewhere around carnivory or omnivory, rather than being dedicated herbivores. So if you stood next to the first dinosaur, you probably wouldn't consider that this was the beginning of an empire. You would see a small, lightweight animal that lived with reptiles much larger and more imposing than itself. And this might be the biggest misconception about early dinosaur evolution. Dinosaurs did not appear and immediately take over the planet. For a long time, their later success invited a very simple explanation. Maybe dinosaurs were simply better. What about if they just had better legs, or faster growth, or more effective bodies? They appeared, outcompeted the primitive animals around them, and gradually took control of Pangaea. But the fossil record doesn't work like that in practice. During the late Triassic, crocodile-lined archosaurs occupied an enormous variety of body plans. Some looked bizarrely like dinosaurs. Others were major predators or armored herbivores, or developed bipedal bodies independently. And statistically, these crocodile-lined archosaurs were actually more morphologically diverse than dinosaurs throughout much of the Triassic. Even the rise of dinosaurs itself doesn't happen as a single event. Their diversity increases at one rate, while their abundance changes at another. Plus, we have a variety of body plans, morphing through time as different dinosaur groups become important in different places at different times. The first 50 million years of dinosaur evolution look less like a conquest, which is kind of the stereotypical idea that you might expect, and they look a bit more like an extended ecological process. Eventually, that evolutionary process created something fascinating. Early dinosaurs began splitting into lineages that would become sharply different from one another, sharply distinctive. One lineage produced long-necked sauropodomorphs, and eventually the largest land animals to ever live. Another produced the theropods, animals that would eventually include Allosaurus, Spinosaurus, T-Rex, and birds. Other dinosaur lineages produce armored animals, horned dinosaurs, giant duck-billed herbivores, and forms that would have been completely unimaginable from anything resembling Nyasasaurus. Many of the fundamental dinosaur body plans already existed by the late Triassic, but dinosaurs still shared the world with major competing archosaur groups. Then, around 201 million years ago, the Triassic ended with a mass extinction. Many of those other archosaurs disappeared, and by the early Jurassic, dinosaurs had become the dominant terrestrial vertebrates across much of the planet. But even here, the reality is more complicated than everyone else died, and this accelerated the success of the dinosaurs, because studies of their body plan diversity show no large immediate growth after the extinction. Much of the evolutionary process had already been producing change. The extinction transformed the scene. Dinosaurs had already spent tens of millions of years learning how to play it, and there is now another question I wish to explore. For decades, the earliest dinosaurs made southern South America look like the birthplace for the group, Argentina and Brazil preserve some pretty awesome Triassic fossils. Tanzania gives us Nyasasaurus, so a southern Pangaean origin has made a great deal of sense. But the fossil record doesn't preserve every environment equally. This is because some places have thousands of fossils, while others preserve almost nothing. And in 2025, researchers tried to account for this directly when they incorporated geographic gaps and differences in fossil sampling to models of early dinosaur distribution. Many of the results instead supported an origin at low latitudes in Gondwana, closer to the equatorial regions of the ancient supercontinent. And this creates an extraordinary possibility. The rocks that would contain some of the most important animals in dinosaur evolution may lie in places where the fossil record is especially poor. Today, portions of those ancient low latitude regions correspond to northern South America and northern Africa, regions where large swaths of rainforest, desert, inaccessible terrain, and uneven histories of scientific exploration make fossils way harder to find. The 2025 study argues that sampling itself may be hiding part of the dinosaur origin story, which is actually pretty interesting. Is the fossil record biased? So Nyasasaurus may generally be the oldest dinosaur we have ever found, or it may be standing immediately outside Dinosauria, or it may simply be one fossil from a much larger evolutionary story that still hasn't been discovered yet. And actually, that might be the most accurate answer to the question of the world's first dinosaur. We probably shouldn't expect to find one perfect skeleton at the exact beginning. The transition happened through populations of small animals, changing gradually over hundreds of millions of years. At some point in Middle Triassic Pangaea, those animals developed a set of features that we now recognize as Dinosauria. They were not dominant or particularly large, and there may have been nothing truly intimidating about them. They were simply one small branch inside an explosion of strange archosaurs recovering from the greatest mass extinction Earth had ever experienced. Nyasasaurus, whether dinosaur or almost dinosaur, captures a glimpse of exactly that moment. And from that almost invisible beginning, came animals weighing tens of tons, predators larger than elephants, herbivores covered in armor, horns, and spikes, with a beautiful diversity of forms, a lineage that would dominate terrestrial ecosystems for well over 100 million years, and one branch that actually never disappeared, because the same evolutionary tree that begins somewhere around animals like Nyasasaurus eventually produces birds. So the world's first dinosaur is important because almost nothing about it would have suggested what dinosaurs were about to become. And somewhere in rocks that may still be unexplored, the animals even closer to that beginning could still be waiting. Thanks for watching, and I'll catch you next time, only on Enchiridion.